Hello, good morning. Good morning, everyone. Hope you're doing well today. It's Thursday, heading towards the end of another week of World Quants. We could carry on with this DW mini project. Done question 1. Did question 2 yesterday. Question 2 was rather easy to do once we used the group by method. Hello, Bonga Musa. Hello, Francis. All right, pandas is the business. Hello, Mustafizer. Hope I'm saying your name correctly. All right, pandas helps us do a lot of stuff rather easily, rather quickly. Hello, Gabrielle, or Gabriel. Question 3 of DW. Most common item by postcode. Hello, Samuel. Hello, Nuwan. Postcode, item name, amount dispensed as percent of total. All right, this amount dispensed as percent of total is a little bit new, but pandas, this is where pandas comes to help save us again. Hello, David. Right, had the same thing. Some practices have multiple postal codes associated with them. Use the alphabetically first postal code. Some postal codes may have multiple BNF names with the same prescription rate for the maximum. Take the alphabetically first BNF name. The alphabetically first postal code thing is not all that difficult to deal with using pandas. So what did I do yesterday? Let's put a line break in here and we could see a bit more. Right, take our practices, sort by postcode. Why am I sorting by postcode? Because this will then arrange things, in alphabetical order via postcode. Because then I could group by code, which is the code of the doctor's practice. Group by code, and this will give us a collection of rows ordered by postcode. The first method right here is an aggregation method. We'll keep the first element within each group. Because we've sorted by postcode, this will give us the alphabetically first postcode for that particular doctor practice code. And then once I have this information for the alphabetically first postcode. Then we can do our join or our merge of these two data frames. Take our prescriptions, merge our unique practices. The scripts data frame has this information about doctor's practice in this column called practice. The unique practices data frame has this information in a column called code. All right, I want to match the column called practice in scripts with the column called code in this unique practices data frame, and this is what we would get. As I said yesterday, well, we don't actually need all this information about the address or this other information from the doctor's practices. So what we might do is we might keep only the information we need from the doctor's practices, namely the code and the postcode. Right, we only need the code to do the matching and the postcode in order to do our later group by. So I could redo this merge, and then I'm just, dealing with a data frame that has a smaller number of columns. Now, I have a data frame now that has a postcode in it and an item name and the number of items. We need to compute the amount dispensed as a percent of the total, right? Percent of the total within that postcode. So what do I need to do? I need to basically compute totals of items dispensed within each postcode. And I need, so like I said, I need two things, right? I need to group by a pair of items, postcode and item name, and I want to know the amount of items dispensed for that pair, postcode and item total. All right, so I'm going to group by a pair of columns, not just a single column, but a pair of columns. And I need to know the total amount of items dispensed within that postcode. So let me make some more room here. So I'm going to take my joined data, I'm going to group by this pair sorry. I'm going to group by this pair of post code and B and F name. I'm going to compute a sum. All right, hang on, before I assign this, let's just see what I get. Right, grouping by a pair, I get what's referred to as a multi-index. And let's only keep the items. I don't need this other information. Do I want this as a series? Do I want this as a data frame? Probably doesn't matter. Let's do things here as a data frame because it's easier to read, partly just the way it's formatted, right? So I take my joined data, my information about prescriptions and postcodes. I'm going to group by the pair, postcode BNF name. I'm going to select the items and compute a sum. Let's reset the index here. Multi-indices are difficult to work with. Let's reset the index. So I have a postcode, I have a BNF name, I have the number of items prescribed for that pair. So my post item totals is this new data frame, post item totals dot head. Again, I have a new data frame where I have a postcode, I have a BNF name, I have a number of items for that pair, for that postcode BNF name pair. Now, what I need, so this is part of what I need to compute this amount dispensed as percent of the total. Now, what do I need? Well, I have totals for postcode BNF names. I need a total of items dispensed within each postcode. Right, now, say for example, basically say I want to take this information right here, group by postcode, select items and do a sum. So I could say post totals. Here I'm right at post item totals, the pair, the post totals. I could take post item totals grouped by post code, compute a sum. Again, I'm going to reset the index because and post, oops, sorry, post item post totals dot head. Right, so within this postcode, there's this many items that were prescribed. Now, what I want to do, so I have a number of items for a postcode BNF name pair. I have a total number of items within a postcode. I want to do two things in some order. I need to, compute a quantity of items, or sorry, percentage of items, right? I want basically 7 divided by 22,731 because, right, this is in postcode B11 for BW. So for all of these within a postcode, I need to divide by these items. Why not directly group by postcodes? Well, we can. I mean, I could take my joined data and group by postcode and select the items, right? I should get the exact same totals. I could take joined group by postcode. I'll select items, do a sum, do a reset index, and I should get the exact same totals. Right, and 22,731. Either way I do it, I will end up with the same result. Right, but I need two things, right? I'm going to group by postcode and BNF name because I want to find which drug was prescribed the most within each postcode. And I do need the total number of items per postcode. So however I get it, I should get the same result. Right, if I group by this pair first and then I take this information and group by postcode, well, it should be the exact same as if I just take the original data and group by postcode. And thankfully it is. Sanity check. Now I need to know what is within each postcode, I need to know what is the item that was prescribed the most. It may not be this ABDEC DPS because I haven't looked at all the postcode BNF name pairs, right? But within each postcode, I need to know what is the item that was prescribed the most. And there's a way I could get this. So if I take my post item totals, group by postcode, and again, I'll take items, and remember before in question 2 we used this IDX max. It was basically saying, well, within this postcode, it's the item at this index at which the maximum is achieved. So, for example, if I look at post items totals, post item totals, loc 1628. This is saying that within this postcode, B11-4BW, this item was prescribed the most, and it was prescribed the 706 times, or the sum. Right, within this postcode YO11 1UB, somewhere in Yorkshire, this item was prescribed the most. The item at this index was prescribed the most. All right, post item totals dot loc 575910. Right, this item was prescribed the most within this postcode, and it was, the total was this number. So, I could use these as the index numbers. So I could take post item totals dot loc, and this should give me one row for each postcode. So they're saying there's 259 distinct postcodes. Well, I should have one row for each postcode, and it will be this item which is prescribed the most. And this will be the number of items, the number of times that drug was prescribed. Now, here is where we could use a bit of Pandas functionality. I'm going to take this data frame right here and set the index of this data frame to be equal to the postcode. Why? Because I want to do a bit of arithmetic. And I'm going to go back up here, and I'm actually going to change this postcode right here so that this post totals, so that the postcode is the index. I can do that by actually removing this reset index. Right, so I have this data frame right here where the index is the postcode. And I'm going to take this data frame right here, and I'm going to set the index to be equal to the postcode. Why? Because I want to do some arithmetic. I'm going to save this. I'm going to say max items is equal to this data frame. So now I have two data frames. One, I have post items head. Post totals. I have this data frame which gives me the total number of items prescribed per postcode. And I have this other data frame that we call max items, which is the maximum, right, which is the item name and the number which was prescribed the most within that postcode. And now I could do a bit of data frame arithmetic. These data frames share the same index. So if I take max items and I divide by post totals, what happens, I get a new data frame, right? And these divisions and BNF names, you know, well, we'll deal with that in a moment. Right, but the idea is that how is this division handled? Right, pandas matches up the indices so that they will match. Right, so Panda says, oh, this has an index of B114BW. It looks for a row in here which has an index of B114BW, and it will take the items here and divide into the items here. It tries to do a division as well between a string and a number. That's why we get NANs. But we could deal with this in a moment. Right, so when this division right here, pandas matches up the data frames by matching on the index. This is why I set the index of each data frame to be equal to the post code. And, you know, I could say max items is equal to max items divided by post totals. Right, I could compute this division, so I only take the number right here, the numeric column. I can still do the division, and I will reset this. This will give me a new series, and I will set that new series equal to this column, because then my max items data frame has the information that we want. Oops. How did that happen? All right, I may need to that wasn't what I expected. Oh, all right, hang on. Let me recalculate. So max items, postal totals. Let's see if I could get this correct here. That's better. I need this data frame right here. All right. Max items is equal to this. That's more like it. Forgot I needed this data frame column right here. I need this as a data frame. That's better. Let's go back and double check. I have postcode, item name, amount dispensed as % of total. I'm nearly there. I need a list of tuples. Sort your results ascending alphabetically by postcode. Take only results from the first 100 postcodes. So we're nearly there. I have a data frame right here, which has should be sorted by postcode already. but I have 259, I want only 100, and I want these things as a list of tuples. So what I could do, for example, like if I take max items index, for example, this gives me this index. I could say use the zip method. I could zip max items index, max items BNF name, max items oops. I zip these things together, and I turn this into a list, and then I take the first 100 items. Right, again, I want a list of tuples where I have postcode, BNF name, and this fraction as a percent of the total. Well, I could say take the index, which gives me the postcodes, this column, which gives me the names, the max items, pass them through this zip function, turn this into a list, take the first 100 items, and I want to call this items by region here if I want to submit to the grader without changing things. Items by region is this. Let's just comment this out, and I get what I get the correct solution. Hello to you too, Patricia. A bit of a belated hello. So, hopefully, again, the ideas here, I hope, are somewhat clear what I'm doing, right? This is all pandas manipulations. If I needed to do this repeatedly over and over and over again, right, I might write a function that would do this for me. If I needed to do this once a week, once a month, etc., I might write a function which would do these kinds of operations for me. Right? I could just feed in the data frame of prescriptions and this data frame of practices, and this function would do these grouping operations for me, do these calculations, and return, either this data frame or this list of tuples for me. So these kinds of operations right here, this is, you're kind of essentially seeing how I go about writing pandas code. As I said, right, to me it's always a little bit of a trial and error kind of process. Like I know what I want to kind of get to eventually. And it's like, how do I build the pieces that will let me get to this solution eventually, right? Like, say, I know I want to get to this kind of data frame. Which has this information that I want. It could either be this data frame or, right, if I reset the index here, then I just have a data frame which has 3 columns, a postcode, a BNF name, and these items as a percent of the total that was prescribed within that postcode. And so, what do I need to compute these percent of totals? Well, I need to know, I need like information about a postcode and a drug name, how many items were prescribed for that pair, that postcode BNF name pair. I need to know how many items were prescribed within the postcode so that then I can compute a ratio. How do I compute a ratio? Well, pandas helps me out to do this. If I set the index of two data frames to match, and I do like a division, well, pandas does the division by matching up like indices. This is, a key thing to keep in mind, or taking one series and dividing by another series. Well, pandas does that division by matching up on matching index for that series. And so, this is why I was like setting the index, or making sure the index right here was set to the postcode, so that when we do this division, then the division is done by matching up on, the index values that match. We don't have to write a for loop. This is kind of the whole point of pandas. It's using NumPy, and it's using the fact that we have an index, and it's matching up on the index values. This leads me, I may have said this to you guys. I know I've said it to many other students in the past, right? If you are writing pandas codes and you find yourself writing a for loop, you're probably doing the wrong thing. Right? So again, if you're writing a for loop when you're operating in pandas, you're probably doing it the wrong way. Because there's probably a better way to do it. Right? Set your indices of your data frame or series you're using correctly. Write a Python function, use the apply method, or do a group by operation, apply some function to your groups, etc. Right? If you're writing a for loop, you're probably doing it wrong in pandas. So I think it's just one kind of lesson, one kind of idea to keep in mind. If you're writing a for loop in pandas, you're probably doing the wrong thing. There's probably a better way to do what you're doing, what you're trying to do. And like I said, you're witnessing how I generally go about writing pandas code myself. This is kind of incremental process, because I know, kind of what my goal is. There could be more than one way to get there. And as I said, if I needed to do this kind of thing again multiple times, I would likely wrap up, the kind of operations I've done inside of some function. where, say, I could just feed in this scripts data frame, feed in the practices data frame. I would get out, say, this, data frame right here, back from this function. So any questions on what I've done? Right, and I mean, like anything with programming, you just don't be afraid to try things out. I messed something up. I did some division. Oh, it didn't work out. Well, I'll go back and I recalculated my max items, and then I figured out how to do this division correctly to get the the result that I wanted. So we got a little bit of time up. We could start on question 4. So, drug abuse is a source of human and monetary costs in healthcare. A first step in identifying practitioners that enable drug abuse is to look for practices where commonly abused drugs are prescribed unusually often. Let's try to find practices that prescribe an unusually high amount of opioids, right? I might be some sort of, agency that's overseeing, or, some regulatory agency which is overlooking the National Health Service in Britain, and I want to say, well, can we find the doctor's practices which maybe are over prescribing opioids? So the opioids we'll look for are given in this list below. So morphine, oxycodone, methadone, fentanyl, pethidine, buprenorphine, propoxyphene, and codeine. They say these are generic names for the drugs, not brand names. Generic drug names can be found using the DNF code field in scripts along with the chem table. We haven't used this chem table before. Use the list of opioids provided along with these fields to make a new field in the scripts data that flags whether the row corresponds with an opioid prescription. So, right, we have this chem data frame here. Let's look at, say, a slightly larger list. Right, it's like what we want to do is we basically want to look at this name. And I want to say, well, is morphine in this name? Or is oxycodone in this name, right? And keep in mind, this this name right here could contain capital letters and lowercase letters, and we want to basically ignore this case. or is methadone in this name, or is fentanyl in this name, etc. Right? So I'm going to check, is any of these strings contained in this name, and I want to, ignore this case. So again, this is where I could use some pandas tools to help me out. Chipro, you want to know about the dead kernel problem? You probably have too many notebooks open. As I've said a few times before, and you don't have a lot of memory to work in. You can't have a lot of notebooks open. If you're running into a dead kernel, close notebooks you're not using. Closing the tab isn't good enough. You might need to go to the running tab right here and shut down notebooks which you aren't using. As I said, closing the tab in your web browser doesn't stop the kernel from running. You may need to shut down the kernel of notebooks you're not using. Only run the code necessary for the problem that you're working on. Right? Even for this mini project, I might need to go back and restart my kernel and only run. Yep, but you may need to only run the code for the problem that you're working on. If you're working on problem 3, don't run the code for problems 1 and 2. Yep, and I'm telling everyone exactly the same thing that I'm telling you. Only run the code for the problem that you're working on. I might have to look. Data isn't getting loaded. I don't know what to suggest at the moment. Don't try and print out these big, these big dictionaries. If you try and print out a lot of information in a Jupyter notebook, it could crash your kernel again, and then you may not be able to load up that notebook because of this large amount of data that you're trying to print out. So we can use some pandas operations, right? Pandas has a string library. So, for example, oops. All right, well, I could try and look into that issue. Samuel, as I've said before, right, you may have to close other notebooks when we run the code for the problem that you're working on. The string library has a so this is how we get to the string library. The string library has a contains function, and I could tell it to ignore case. So, right, I could use this here to filter. Right, say, does this name contain morphine, ignoring case, right? And this will give me a true or false. And of course, right, this will filter and give me the values. This will filter and give me the values where this evaluates the true. Well, once again, if you're working on problem 4 in DW, don't run the code for problems 1, 2, or 3. Right? I may, as I said, I may need to go back and stop my kernel before I would be able to successfully finish the code for question 3, because I have some big data structures that I've created. In answering questions 1, 2, or 3, I may need to restart the kernel and only run the code for question 4. I want to search not only for morphine, I want to search for any of these. I could search for all of these by that's essentially doing a regular expression type of operation. Right, take a vertical line, join my list of opioids. So vertical line, join opioids. This contains right here is basically doing a regular expression type of thing, right? Look for morphine, the vertical line says, or look for oxycodone, or look for methadone, or look for fentanyl, etc. So I could search for any or all of these. And you can see, well, right, this one has codeine, this one has morphine, this one has codeine. All right, I will look into that issue. I think things were still running for me fine yesterday. Oops, that's PW. Let's try following. Let's get through there. For some reason, this won't let me. One second here. Downloading the data just fine. This may crash my kernel because I'm nearly out of memory. Things are working okay with me. I shall look into this more. Is it not downloading the data? Has it not downloaded the data correctly? Because this code was working, this code worked okay for me here. I'll try it out later on some of you guys' pods here. And it did kill this kernel here. Again, because of the memory issues. Load. We're nearly out of time here, right? But so again, right, I could use this to search for, does this contain opioids? The idea here is this chem sub column. I want to match up with the BNF code. So the BNF code right here, which I want to match up on this chem sub column name right here. So what we could do is we could say, well, you know, right, I could identify these chemical substances that whose name contains one of these opioids. I could say opioid codes is this. Select the chem sub and this may appear more than once, so I could take the unique values of these names. Opioid codes, right, is a this basically gives me like a NumPy array. I could look and see, is this BNF code in one of these opioid codes here? And I can add in a column in my scripts data frame to indicate whether this prescription is for an opioid or not. We're out of time, and so we'll continue with this next week. I'll look into the issues on the PW Mini project. It's strange. Things are working for me. Are you guys loading up and trying to display this big set of data? Don't do that. I'll have a look. I wish you all a pleasant weekend.